Hello and welcome to Morehouse's Math Menagerie. Today we're going to be talking about chi-square test for homogeneity. This test compares the distribution of a variable between two or more subgroups of a population. We are going to be looking at gender and eye color, and this is data sampled from AP Stats students. And we want to see if the distribution in eye color is different between females and males. The eye color represents our response variable, and the males and females represent our subgroups. The idea here is to compare two different sample distributions. Step one is our parameter and hypotheses. Our null hypothesis is that the distribution of eye colors are the same for both genders. The alternative hypothesis is that the distribution of eye colors are not the same for both genders. For our conditions, this is very similar to the goodness of fit test. We need random sampling, which this is a convenient sample since it was my students, but normally we would check for random sampling. We need to check our 10% condition for independence, and we need all expected cell counts to be greater than 1 and no more than 20% to be less than 5. This condition is difficult to assess until after we run our test, so we will check this later. For our calculations, the test statistic is still our chi-square, and it is calculated by taking the sum of our observed minus the expected squared divided by the expected. Now, this chi-squared test statistic has a degrees of freedom of number of rows in our table minus 1 times the number of columns in our row minus 1. We will be using technology for all of these calculations, as they can get quite daunting to do by hand. In your calculator, we need to set up a matrix. So we're going to hit second and then the x to the negative 1 power button on the TI-84. That will get us to the matrix menu. If we tab over to the right and hit edit, we're allowed to change the size of matrix A to a 5 by 2 matrix, and then we can enter the observed data. We will then quit out of the matrix menu and go to Stat Tests and then chi-square tests before we ran the chi-square GOF test. This time we're going to run just the chi-square test. We will select the matrix that we built, matrix A for the observed. Matrix B will automatically be in here as the expected. We don't have to do anything with that, but just make sure matrix B is in here. And then we can hit calculate. The output for the chi-square test gives us our test statistic of 3.8211 and our p-value of 0.4307 and our degrees of freedom of 4. Now, when we ran that chi-square test, the calculator automatically calculated all of the expected values and put them into matrix B. So if we go back to our matrix menu and go over to Edit and select Edit Matrix B, you can see here Matrix B has been filled with all of our expected values. Note that none of them are less than 5, so we have met our large counts condition. On to our final step. Our p-value of 0.4307 is greater than our significance level of alpha equals 0.05. Thus, we fail to reject the null hypothesis in favor of the alternative hypothesis. There is insufficient evidence to suggest that the distribution of eye colors are not the same for both genders. Thank you for joining us today. I will leave you with this quote from John Ruskin.